Good morning, student. Today we will solve some numericals on this circuits which contains the resistance. We can see this circuit diagram and we have to find the resistance between the terminals A and B. Okay, so here we can see it is a this A and C is short circuited and this B and C is short circuited. Okay, so we have to do something rearrangement to these connections. Okay, so as it is, we cannot find this problem, or it will become little bit difficult. So I will just solve this. I will try this. So this is A and B terminal. Okay, A and B terminal is there, and the resistance between this is given. This is 8 ohm, and then this A and C terminal, it is resistance is 6 ohm, and between C and D it is a 10 ohm resistors, and between this it is a 12 ohm resistors. So we have seen that there is a short between this B and D line. Okay, and there is also short between this B and C line. So we can draw like this. So there is a short between this B and C. So we can draw this like this, that there is a short line between B and C. Okay, and there is also A and D. There is also one short line. So instead of this, we can draw like this. Okay, so this is the line, and even now we cannot solve this because this is also this also becomes some little bit complicated. Again, we have to just rechange these terminals. So we'll just interchange. D terminal will be at the top side and C terminal will be at the bottom side. And let us see what will happen. Okay, whether it will become simpler or not. So again, there is a between A and B, there is a 8 ohm resistance. Okay, then this is A terminal, this is also A terminal, this is also B terminal. So we will just interchange this. So D terminals will be upward and C terminals will be downwards. Okay, so this is the D terminal and this is a C terminal. So between D and C, we know there is a 10 ohm resistor. Between D and C, this is D and C. D and C, we know between D and C there is a 10 ohm resistor. Okay, now between A and D, there is a short line. Between A and D, there is a short line. So between A and D, there is a short line. Okay. Similarly, between C and B, you can see the C and B there is a short line. So C and B there is also short line. So now the remaining resistance are there. 10 ohm is there, 6 and 10 ohm resistance. So this is a 6 ohm resistance and this is a 12 ohm resistance. Okay. Now the 6 ohm resistance is connected between A and C. 6 ohm resistance is connected between A and C. So the 6 ohm resistor connected between A and C. So this is A. Okay, this is A. This is also A, and this is connected between A and C. So in this way we can connect. Okay, now the 12 ohm resistance is connected between B and D. So 12 ohm resistance is connected between B and D. So this is the B. This is also B, and this is also your D terminal, and in this way we have connected between B and D. Now the picture is very clear. We can see that all the resistances are connected in parallel. Okay, so we can find here equivalent resistance, that is 1 divided by RAB is equal to 1 by 8 ohm plus 1 by 10 ohm plus 1 by 6 ohm plus 1 by 12 ohm. And if you find this, you will get this 19 by 40, and therefore equivalent resistance between these terminals are AB is equal to 14 by 19, and this is equal to 2.105 ohm. So this is the equivalent resistance between the terminals A and B.